Hey campers, it's Emmy from Nature. I'm here to give you a little bonus activity to go along with your nature choice activity called Capillary Action. So this is a really cool science concept that's really fun to learn, uses really simple materials. So if you haven't done it already, I'd say go ahead and do it because I'll give you some more experiments to try that go along with that. And it's really fun with some pretty surprising results. And capillary action is a really interesting, fascinating thing that happens around us all over the world. We don't even realize it's happening, but it's super important for the natural world and for art and for science. We see it everywhere. So it's a really cool concept. So go ahead, grab that activity sheet, see if you can do that activity, and then come on back and we'll add some more fun little twists to it that you can try as well. All right, campers, so here we are with our setup for our capillary action activity, just like in the handout that you got. I've got my old plate here. It doesn't matter if I get a little bit of marker on here, it won't hurt anything. That'll keep me from getting marker on my table, or you can use newspaper underneath it. Always a good idea to protect the table or the surface that you're working on. So we did this activity last time with a piece of paper towel, a marker, and a dish of water, and a little spoon to dish it out with. So we're gonna just repeat that same experiment from the activity sheet so we can take a look at how it works together. So I'm just gonna draw a little black line here. I really like using black marker, and remember this is a washable marker, not a permanent marker. I like using black marker because it takes all different colors of ink to make up black marker ink. So if you had green, it would be yellow and blue. If you had purple, it would be red and blue. But black, it takes a bunch of different colors all mixed together to make that black. So it's interesting to see what those colors are. So what we're gonna do is, just like in the instructions, gonna take a little dish of water, just a little cup of water, dish of water, so you're not gonna need much, and a spoon, and we're just going to drop the water right on that line, just a few drops of it, and see what happens. Now, you can even hold it up this way, and you can see that instead of gravity pulling the water down, something's pulling it up. So some gravity, some water's going down here, but then it's also continuing to go up this towel against gravity. And what is making that happen is that capillary action. It's the same thing that when you dip a brush into paint, the paint will suck right up on the brush, or the roots of the plants will pull water up from the ground, upward against gravity to the leaves or to the top of a tree. So that's capillary action at work. So there are three properties of capillary action happening. So one is cohesion. The liquid molecules like to stick together. The little tiny bits that we can't see that make up that liquid, they like to stick together. The second thing is adhesion. Those molecules that are stuck together like to stick to other things too. So they like to stick to the tiny little fibers and the tiny little spaces in between those fibers in this paper towel. So as they stick together and they stick to other things, they kind of pull each other up with them. And then the third is surface tension. And that's the thing, if you're on a lake, or like Lake Abenaki at camp, and you see those little tiny bugs floating on top of the water, that is because of surface tension. They're super, super light and very spread out. Those legs are very spread out. So the top layer of the water, there's something about the molecules that the very top layer, they like to stick together even more at that very top. So they form kind of this tighter layer of molecules, more densely packed together, so it makes it easy for something to float on top of it. A feather will float on top of it, a leaf will float on top of it, a little water bug will float on top of it. So that surface tension, what it does is at the top of this water right here, as it goes up, as it pulls in and gets tense on that top, it continues to pull all that water up through all the tiny spaces in between the tiny particles of paper. So that's what's happening there. Now you can see some of all these different colors forming right there, and we've got some really pretty, we've got some blues and turquoise and all sorts of really pretty colors there. So why the colors separate is because The ink, some different colors have bigger particles than others, so it's easier for the water to grab some of those particles and bring them upward, whereas other particles are bigger. So the darker blues must have bigger particles. It takes them a little bit longer to pull up through that capillary action into the paper towel, so that's why the colors separate like that. It has to do with the size of the microscopic little particles that make up that ink and how heavy, how big they might be compared to each other. Okay, so I'm going to experiment with a couple different materials and see if we get any different results. We've got a piece of regular paper, and my guess there with the regular paper is it's going to act pretty differently from the paper towel because the spaces in between these particles of wood that make up the paper, I think they're more densely packed more tightly together than in the paper towel. So I think it's going to act differently. I also have a coffee filter here, so we're going to try to see. Again, I feel like maybe they're a little bit more tightly packed in there, so maybe it won't happen quite as fast. And then we have just a tiny bit of toilet paper. Now it's just a little bit because we know toilet paper is precious right now, okay? So just a little couple squares of toilet paper that I'm trying this with. All right, so let's try the piece of paper. I'm going to fold it kind of like the paper towel was, kind of keep the two things similar in our experiment. All right, and get my marker out right here. Do my thick line, my dish of water. All right, what do you think? What do you think is going to happen? Let's try it. Oh, look at that. So the answer is not as much is happening. So when I lifted it up, some of the gravity pulled the water from the top layer and just sloughed it right off because it didn't have enough time to absorb. It's taking much longer to absorb and much longer for that capillary action to happen. As you can see, it's happening a tiny little bit. It's starting to come up over the top of that line, but it's happening very slowly. So what do you think? Was my guess right? Do you think that the particles in the paper are more tightly packed together? Because that water, it needs spaces to move up through. So it needs a little bit of room to move up in between the different little bits and particles of the paper. So that's sponges. That's how sponges soak things up. They use capillary action. So if you drop a sponge on top of some water, it's gonna pull that water right up into the sponge because of capillary action, because we know sponges have lots of little bits and spaces in them, don't they? So you can see that coming up right there, so much slower. Okay, so then my guess was that the coffee filter would be the second slowest to pull up the ink. So let's see. I think it's going to be maybe faster than the paper, but slower than the paper towel. Because if you feel the coffee filter, if you look at it, you can see the spaces in between the particles a little bit more than you can with just a piece of paper. The piece of paper almost seems like it's fully solid because there's not a whole lot of spaces. All right, so drop of water. Ooh, definitely faster. Look at that. Okay, so some of the water went downwards, but then zoom, we've got lots of capillary action happening right there. So it's pulling all of those colors right up. But it's definitely pulling the colors up a little bit differently. So far it seems like maybe the colors are separating just a little bit differently with the coffee filter than with the paper towel. So we can see a little update on how our paper towels are, and look at all those beautiful blues and that black. So you can see some of the different shades of blue being pulled right up. So I think maybe not quite as quickly as that paper towel, but definitely not as slowly as the regular piece of paper. Going back to the regular piece of paper, that's all it's done so far, just that tiny little bit of capillary action right there. Okay, and now we're going to move on to our last material for our experiment, and that is our toilet paper. So just a little bit of toilet paper. We're going to do the same thing with it. Now, what do you think? Do you think it's going to be more like the sheet of paper where it doesn't really soak up much of the water at all, it just rolls off? Or do you think toilet paper needs to be absorbent? I think we know that toilet paper needs to be absorbent. So I'm going to guess it's going to be a little bit more like the paper towel, but maybe not exactly the same. So there we go. There's our black ink. Our dish of water. Go right ahead and drop and see what happens. All right, yeah, so definitely more similar to that paper towel, definitely absorbs some of that water, and we have some capillary action happening, pulling up the water, pulling up the ink particles with it, and seeing some separation of some colors. Again, I don't think it's quite as fast as that paper towel, but it's definitely faster than the regular paper, and I think it's also a little bit faster and a little bit more ink is being drawn up than the coffee filter. So pretty neat what's happening there. We can see some different colors forming already. It's pretty cool. This kind of spread out in all different directions. Paper towel, it went up a little bit more, and this one kind of spread out a little bit more. So that's cool. And that is capillary action happening down there also, pulling it downward as well, but it's also getting some help from gravity, whereas this is just capillary action, pulling it up against gravity right there. So pretty neat. And then going back to our paper towel, look at all those colors. That's amazing. You've even got some pink showing down there. So my guess is that the pink or the red particles in this ink are the largest and heaviest, so they weren't able to move quite as quickly up as the light blue, especially that nice turquoise color, the darker blue, the purple. So I think the reds and the purples have stayed behind because those particles, the red particles, are a little bit heavier than the light blue particles that make up that ink. So very neat. So go ahead and give this a try at home. Find some different materials. Experiment with some different colors, see what happens. If you use a green marker, do you get the results that you expect, or do you see something different? Because different markers will do different things. So maybe even try 2 different brands of the same color, 2 different brands of black, 2 different brands of purple, and see how the colors that make up those the ink in those markers, see how the colors differ. So enjoy and have fun, campers.